Hey, okay, we're going to talk about the ones where they're more complicated. So usually you're going to have a number next to the x squared plus a number next to the x minus a number all by itself. If one of these is missing, then that one is just going to be 0. So if there's no number by itself, just assume it's 0. If there's no number next to the x, it's 0. But I have a number for all of these. What that means, if I put letters in for each of those, so that's ax squared plus bx plus c, guess what? We have a formula that'll tell us where the vertex is. This is really important to graphing because it gives us our first point when we graph it. So it's just going to be the negative b, whatever that b is, over 2a. So let's do that for this one. X equals negative 6 over 2 times 3. Well, what do we end up getting? We get 6 over 6, so negative 6 over 6. Divide those. 6 divided by 6 is 1, so we end up with negative 1. Now, that just gives us the x-coordinate. Remember, with that vertex, it's an actual point. So we actually have to put that into the formula to find the y-coordinate. So if we do y is 3 times negative 1 squared plus 6 times negative 1 minus 4. Okay, we're going to get negative 1 times negative 1 is 1 times 3. Negative 1 times 6 is negative 6 minus 4. So we end up with y equals 3 minus 6 minus 4. Altogether, we end up with what? 3 minus 6 is negative 3, minus 4 is negative 7. This tells me I have a vertex where the x is negative 1 and the y is negative 7. Okay, now we're going to try to draw this. So I'm going to go ahead and draw my y value, my y-axis, and my x. I can see that that y is really low, so I'm going to move my axis up a little bit, just so I have a little more space down here. Okay, so first I'm going to plot this point because that gives us our bottom point right where it changes direction. So that's a negative 1, comma 1, 2, 3, 4, 5, 6, 7. Okay, now here's the interesting thing. Remember that table that we had where we have 0, 1, 1, 0, 0, 1, 1, 2, 4, 3, 6. Okay, those are all from the vertex. So this tells me I could go to the right 1 and up 1, or right 2 and up 4. It's just the same graph, but it's moved over, except it's also being multiplied by 3. So if I look at this and I add an extra column for it multiplied by 3, I end up with 0, 3, multiply that by 3, I get 12, multiply that by 3, I get 18. So now my graph is go to the right 1 and up 1, 2, 3. Go to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now remember how we had the symmetry on both sides? If we go to the left, then we go up 3. If we go to the left 2, we end up 12. We end up right on the other side of that one. So we end up with a graph that looks like that. Okay, now we're going to talk about those important pieces that we talked about before, and I'm just going to put them up here. Ready? Where's the vertex? The vertex here that we found was at negative 1, negative 7. Okay. Where's the axis of symmetry? If you look at the graph, it's always in relation to where that x-coordinate is for the vertex. And that vertex was at negative 1, negative 7. So that's the x-coordinate equal to negative 1, right? What about the y-intercept? The y-intercept is a little bit different here. Here, if we look at where it crossed the y-axis here, It was to the right 1 and up 3. Well, where is that? That's actually down 4. There's another way to find that. If you look at the equation, remember for the y-intercept, the x-coordinate has to be 0. In order for it to cross that y-axis, that x-coordinate has to be 0. There's another way to find it. You could just put 0 in for x. 0 in for x here. Those drop out and we always get -4. That's the c value. Guess what? The y-intercept is always equal to just that number that's all by itself. So that's going to be equal to -4, because in this case, our c value is -4. It's always equal to that, right? Let's talk about the domain. Domain for all of these is always all real numbers. You can always put any number into this equation and you can do the calculations. That's always all real numbers. But let's talk about the range. Remember, the range is dependent on where that vertex is. Notice the vertex is here right at -7, and it shows me that the graph is everything above it, which means there can't be anything below it. And I'm always going to put the range in terms of y. So I'm going to say the y has to be greater than or equal to -7. That's going to be my range. So I'm going to do another example in just a minute. This had all the explanations of whys and hows. I'm going to do another one and kind of run through it quickly with the same information. We'll go from there.